Hello, this is a recording of the discussion for experiment 6, which is on buoyancy. So, in this experiment, yung objective natin ay makakuha ng density ng fluids using concepts related to buoyant forces and densities and apparent weights. So, isa pa, not just the density of fluids, but also to calculate density ng mga objects using the same concepts. So let's discuss a little bit of a background on the experiment's concepts. So experience dictates that when a big wave is coming your way while you swim on the beach, you feel a strong force either pushing you or pulling you back in the water. You also find yourself floating in the sea much easier than in the air. So ito important kasi this is our concept for today, which is a force called buoyancy or buoyant force. So ang buoyant force, basically, it's the force that enables you to float when you are immersed in a fluid. So the concept of a buoyant force goes way back. So 2,200 years na rin na nakalipas. So basically, it says that a submerged object in a fluid weighs less by an amount equal to the weight of the displaced fluid. So ito ay given as the following equation, F sub B, where ito ay rho sub F is your fluid density, G is just your acceleration due to gravity, 9.8 meters per second squared, and V sub is the volume of the object submerged. So if your fluid is incompressible, so ang incompressible fluid just means that your density is constant. Yung volume ng submerged object mo is equal to the volume of the liquid displaced. So, yung density ng object mo is equal to rho is equal to M, mass ng object, divided by the V submerged. So, dahil sa principle na ito, yung volume of the object is equal to the volume of the liquid displaced. Yung terms na ito pwedeng palitan as follows. So dahil dyan, magkakaroon tayo ng isa pang formula, equation 2, that describes the weight of your object in terms of your buoyant force. So if we play around with these first two equations, we should get another formula we use for our object density. In terms of its weight, the buoyant force, and the fluid density. So dito sa figure 1, makita natin ang isang schematic diagram of the entire system. So ang blue line na ito represents the surface of a fluid and meron tayong box. Ngayon, if yung box natin ay i-submerge natin sa fluid, the fluid volume will increase, or well, the reading will be increased rather. Madi-displace yung fluid and the volume of the displaced fluid is equal to the volumes of submerged volume. So itong black na ito, yung corresponding volume nito ay equal dun sa volume na ito ng fluid. So now, let's consider the free body diagram shown in figure 2. So from this figure, we can deduce that the weight of the object is given by the tension in the string. So yung experiment dito, similar sa ganitong case, wherein may isasabit tayo na object.
So let's see what is the weight here. So as you can see here, the weight is 500 grams. Or to be more precise in physics, the weight is 500 gram force.
So paano niya nakuha yun? Basically, yung tension nga na na-experience dito pag sinabit mo yung object mo is just equal to the weight. Actually, yung setup na ito is the concept behind most weighing scales. So the tension in air, yun yung weight ng object mo. You will be using this information later on in the experiment. So using the relations we have so far, we are able to define this particular equation that relates the buoyant force to the tension in air and yung tension na naranasan ng object pag na-immerse na siya sa fluid. So you'll use this equation as well further in the experiment. So materials. So basically, may isasabit tayo na tatlong weights and we will submerge them carefully into water. So dahil hindi naman natin ulit gagawin ito, we'll skip these instructions. But you are free to read them in your own time. So dito, meron tayong measurement of a volume ng water lang inside a graduated cylinder. Let's look at this in more detail. So zoom in tayo konti. So kapag wala pang laman maliban sa tubig ang graduated cylinder nyo, the experimental setup is set up in a way na may 60 ml ka ng tubig. So once you submerge your object inside, magkakaroon ka ng displaced volume. So tingnan nyo dito. This is the bottom of your object. And now, we measure with respect to yung upper boundary na ito. Ito yung bagong displaced volume natin. Ito yung volume na bago. So, the displaced volume is the difference between the initial and the final. So, in this case, laging ang initial volume ay 60 ml. And in this particular case, the final volume is 60, 61, 62, 63. So 63 ml minus 60 ml should give you a displaced volume of 3 ml. So yung image naman dito sa pinaka-right, this is the experimental setup. So itong machine na ito, it's just a way para mag-measure ng force or tension. Naka-connect siya sa sensor dito, tapos ito ang reading mo. So these are already pre-recorded for our case dahil nga online. So yung iba dito, you will have to measure your data points, final volumes to get yung displaced volume for the experiment. So important for the rest of the data. Basahin nyo na lang ulit yung instructions. So I'll skip directly to summarizing the data sheet. So this is our data sheet. Sa pagkakaalam ko, itong displaced volume sa ovle I already filled out, but you can do it on your own then to calculate using the measurements. So you have your T air, tension sa air. So again, this is just your weight. And you have your tension when your object is submerged, and you are to calculate the tension force every time. So here you will be using equation 4 to calculate the tension values. Next, table W2 and a graph. So, related itong dalawa and they will use the same data points. Buoyant force versus volume submerged. So you have a submerged volume. Actually, displaced volume pwede rin, di ba? Kasi we described earlier how these are equal. So you will be plotting this buoyant force versus your displaced volume. Here, kailangan kompleto ang graph elements. So if you recall sa experiment 3, we define these elements: axis labels, trend line equation, chart title, grid lines, axis units, as well as legends. So ang grading system sa graph will depend on how many of these elements you include. Syempre, aside from the fact if tama ba yung graph. So from the graph, kukuha kayo ng trend line and you will use that to calculate the density. So papansin niyo, buoyant force versus volume submerged. So to solve for the density of the fluid, you will have to use equation 1. Kasi may FB ka and V sub dito. Let's go back. Relative deviation. So to calculate the relative deviation, you will have to use concepts from equation 1. Experiment 1. May formula yan. The true value or theoretical value of your water density is 1 kilogram per liter. Exactly 1 kilogram per liter. So you use that for your calculation. So next, table W3. These are 3 trials. And again, given ang weight and T sub, you can calculate your force here. And using yung related equations, you can calculate for the density of your object. So what equation do we use here? You can use this one. You can use this one. Either equations 2 or 3. Pwede gamitin for that one. So for this part, you are to include calculations, pero tables W3, W4, and W5 are actually identical in calculations. So I only need calculations for one set of values. So lastly, we have questions. So these are all about the densities of our objects. So here you will use concepts from your density lessons in Physics 71. So this concludes our discussion for experiment 6. So good luck with your experiments and thank you for watching.